Okay, so what are we gonna do here? Draw a picture, absolutely. So we got a cylindrical oil can, so we need a cylinder, right? So something like that. With a top and bottom, has total surface area here. Well, what are the variables probably gonna be?
Radius and then height.
Radius and height, that makes sense. Okay, so we've got the radius and height. And so then in terms of that, we know what or you were given, but you probably know by now. What is the formula for the volume of a right circular cylinder?
2 pi RH.
2 pi r. Oh, no, sorry, we want to do area. Sorry, I'm doing the wrong thing, aren't I? I was going to do volume. See, that's not quite right, but it's area, right? So surface area. So surface area equals the lateral area, which is 2 pi RH, right? That's the barrel of the can. Plus the end caps, which would be what?
2 pi, no, yeah.
That's right, yeah.
R squared.
Yeah, pi r squared, but there's 2 of them, so 2 pi r squared. Good. Okay, what's the problem with that, obviously?
2 variables.
2 variables. Okay, so, we are doing volume. What am I doing? Okay, well, there's our surface area equation, but really what we want is volume, right? It wants you to maximize volume. I didn't even read the question. So what is that? That's an easy one. Volume is,
Volume of
no,
r pi r.
pi r squared is the area of the circle and then times h, right?
Okay.
Okay, so that's got two input variables, 2 independent variables. So we need to come up with our equation of constraint, which is right here, isn't it?
Would
Right.
you want to set the equation to 24?
We do. And so let's actually, I'm just gonna do this. I'm just gonna grab all that stuff, move it down here, and we'll just make that equal to 24 instead. 24 pi, yeah, that pi, I helped you out with that pi a little bit. Why is the pi so helpful?
Because you can cancel out all the other pi's.
Yeah, we can cancel all pi's, right, that's good. We could divide everything by pi.
2 pi's.
Was that pi?
Yeah, we could divide everything by 2 pi, couldn't we? So really, we could divide everything by 2 pi and get RH plus r squared equals 12.
Was that pi on the test? 'Cause I totally-
Yeah.
I totally missed that part.
Yeah, that's kind of.
No, in life, every time you get a chance for a pie, you want to take it. Pie is delicious. You don't want to miss those opportunities. Never. Okay, so here's our secondary equation. Which is the variable? We got to think about this a little bit now. Which is the variable that we want to substitute? For sure, h, right? H, because h shows up. It's linear there and it's linear there, right? R would be a bad idea. Because if I solve for r, that's going to be hard to do. I've got r squareds and r's. That's going to be really hard to do, right? We could make it work, but man, it wouldn't be worth it. So we'll solve for h, and h equals 12 minus r squared over r. Put a box around it. There's our substitution equation. Okay, let's pause there. Does that make sense? Okay, so that's the structure we always want. Define the variables. We're going to start off with our primary equation, and then, if necessary, which it is, because I've got two, I've got to use my secondary equation to make a substitution, right? Okay. So that culminates with our primary equation now as a function of one variable, which gets us ready to do calculus, right? So what is our primary equation as a function that? Well, I'm going to make this substitution. Yeah. So what do I get? V equals V of R. That's the one we're going to have left, right? Because I'm going to substitute my H. So V of R equals pi R squared times this, right? Okay, times H, which looks like 12 minus R squared over R. Okay, so what should I clearly do to that? I want to distribute here, don't I? And there was, in some cases, people wanted to treat this like a product. Now, we don't want to do that. That's hard, right? Product rule is, especially when you've got one of the factors in the product rule is this quotient. My goodness, that's really hard. I mean, it's not difficult in terms of the complexity, but it's difficult in terms of the amount of work you're going to have to do, and it's unnecessary. We want to turn this into a polynomial, which makes life really easy, right? So we could distribute the r squared through, and then just get v of r equals pi. Let's just leave the pi out front, right? We don't need to pull that one through. Just leave that out front. Times, what are we going to get? 12r squared over r is going to be what? 12r minus r cubed, right? R to the fourth over r to the r cubed. Okay, so here's where we want to get our domain then, right? We want to know where are we looking for these critical numbers. Well, let's go back to our picture. Mathematically, there is no restriction, is there? Right? But physically there is. R is going to vary between what and what?
0, not including 0. 2,
Okay, so 0 is going to be the lower limit. Good. Up to, now let's look at this one. So as R gets bigger, H gets smaller, right? Everybody agree? Okay, so what's the biggest, if H were to go to 0, what's the biggest that R could be? Right? You kind of get what I'm saying here? This is a good way to think about this. Remember, these two variables are almost always going to be antagonistic, right? They're going to be inversely related. As R gets bigger, H gets smaller, doesn't it? And vice versa. So as R goes to 0, H is going to get big, right? As H goes to 0, the end caps get bigger. Well, what's going to be the limiting case there? And we can look at it in terms of this equation here if we want to. If H approaches 0, what's that one going to give us? Oops. Oh my gosh, what's this doing? Okay, so let's look at this again here. So what's that going to do? As H goes to 0, then I end up with the equation 0 equals 12 minus r squared over r, right? So what's r going to? Square root of 12, right? Because this fraction would go to 0 when the top goes to 0, right? So we've just got the square root of 12, which is what, 2 radical 3? Does that make sense? Okay, so that's the upper end of our limit, isn't it? Okay, make sense? So we only need critical numbers in, within that domain. And I could put, I could put square brackets around that, but what's going to happen in both those cases? What's going to happen to the volume? It's going to be nothing, right? So we know that, those aren't going to work. So we're going to look for an interior critical number. All right, so now we've gotten to this point right here. We can do calculus, right? So let me see if I can grab this and go.
just drag on the corners.
Oh, maybe. Oh, it didn't do it, unfortunately. Try one more time. Well, that's better. I'll take that. Okay, so I'll copy. I just want to give myself, I'm trying to think about this in terms of the notes I'm going to produce for you guys so they're good notes, they're readable. There we go. Okay? So there's the function. Now let's do calculus. So first derivative, right? So what's that gonna give us?
Pi is a constant.
So pi times minus,
VR squared.
okay, so then we know from that v prime equals 0 when r squared equals 4, right? So what's r gonna equal? Plus or minus 2, but we only want the one that's in our domain. Right. So when r equals 2, okay? And then v double prime equals pi times what?
-6.
Okay, so that tells us something important too, doesn't it? That tells us that v prime is what for any number in our domain? It's gonna be negative, isn't it, right? For any positive value of r, we're gonna get a negative second derivative. Okay, so this seems, I mean, it always kind of works this way, doesn't it? The calculus really isn't that bad. The tables are easy to draw. So we end up then with the table. On our domain from 0 to square root of 12, we get, what was it, 2? 2 was our 0 of the first derivative, negative for the second.
Is x supposed to be r?
Oh, it's supposed to be r. You're right.
Is it okay if we wrote it like that by accident?
Oh, yeah, I wouldn't care. I would take it off that.
Cause I meant to have it as long as writing, x and then y prime, y double prime.
Yeah, that's fine.
I never changed those.
I don't care about stuff like that. Right, does that make sense? So then that's it, right? There's our maximum. What's the question actually asked for?
Just the dimensions.
Oh, I kind of messed that up, didn't I? Let's see.
Yeah, we rated it, just have to plug in top of those.
Oh, I lost my V. There we go. Just for your notes, now it'll look pretty in your notes. Okay, so it wanted dimensions?
Yeah.
Okay, so then R was 2, what's H?
4.
12 minus 4 is 8, over 2 is 4. Okay, so, yeah, so we get 2 centimeters radius, 4 centimeters height, that's gonna do it. Okay, maximizes volume. Okay, make sense? All right. Questions on that process? Okay, let's keep going.
I know how to do this one. It's all.
Okay, yeah, you're gonna probably kind of kick yourself on this one, because this was a pretty easy one. This was a good opportunity. All right, so the number that most exceeds its square, what's our variable? X. X is some number, right? So then, what's the primary equation that we're setting up, some function? Call it whatever you want. F, I mean, so f of x is what in this case then? Most exceeds its square, so how am I gonna write that? Yeah, right? Right? That's the most, means the most bigger than its square. So we wanna know when is this function x minus x squared maximized? What's the domain? All reals, right? I mean, it could be negative too. It doesn't tell us anything's limited, right? So,
Does it make any sense for it to be negative though?
no, right, the math gods will take care of that for us, but
So
It
like
would.
if we did put 0 to infinity.
It'd be fine. Yeah, but I mean, you could say negative numbers make no sense, and then
Yeah.
put 0 to infinity.
Oh,
Yeah,
okay.
that's fine. So what about here? What do I do? Take a derivative. What do I get? Okay, and while we're at it, f double prime is? Okay, so it's always negative, right? And we know that f prime equals 0 when x equals 1/2. So this is a pretty straightforward table. We get one critical number at 1/2. It's a 0 of the first derivative. We get a negative second derivative, so that's a maximum. Done.
So it was 1/2?
1/2 is the right answer.
What?
Yeah.
So we get credit just for giving 1/2. I got
A tiny bit of credit. You get a minor amount. Yeah. Yeah, that is it though. Yeah. What's the domain of all numbers that exceed their square period? Yeah, x is greater than 0 and less than 1. That's it, right? You got a pretty tiny domain of even answers where you even get a result that's positive, right? Yeah. Questions on that one? Okay. All right.
I just want to know if I got the answer right. Because it looks like I didn't know that it worked.
Okay, I think this is a pretty important one to go through. I can see honestly why this would have been a pretty hard problem.
Oh,
There was
really?
one that I didn't go through that I probably should have, but this will be our example.
Weird.
I like this problem. This is a hard problem, and I think a lot of times people don't like to assign problems like these because they're hard. But there's an important reason why I think you need to see stuff like this, because it's a weighted problem, right? You have some weighted area because the cost per unit area is different for different parts of this figure, right? So we know if the container's gonna have a regular base, regular sides, and no top, and they tell us the volume's gonna be 4, they tell us that the width of the base is to be 1 meter, right? So let's draw a picture of this thing. So it's gonna be, would you agree, it's gonna be something like so that would be maybe 1, right? The width of the base is 1. What's the length of the base? X, okay. What's the height? Y. That makes sense, right? Those have to be variables. I'm not giving anything about those. What's the primary equation asking for? It's going to be a function for what? Cost. Okay, this is what's a little strange. So let's look at this primary equation. It's going to be a cost function. And how are we going to do that? If the material for the base costs $10 per square meter, how am I going to write an expression that represents the cost of the base then?
It's 10 times x. This base.
Okay, so I'm going to do this, instead of being real specific, does it make sense that it would be something like, and I'm even going to put units in for a second. It's going to be 10 dollars per square meter. Times the area of the base, right? Does that make sense? Because we've got an area times a cost per unit area, right? Is going to give us a cost, isn't it? The units of the base are going to be square meters, and so we can see that the units would cancel and I just get dollars, right? What about the other part? Well, that's going to be the sides. We're going to get 5 dollars per unit area, per per square meter times the area of the sides, which I'll call the lateral area, right? Everybody see that? Okay, so then we can be more specific. That's gonna look like, we can ignore the units now, that's gonna be 10 times, what's the area of the base? X times 1, right? So it's just gonna be 10x plus, I'll circle that, so that's the same plus sign, 5 times the area of the sides. Well, what are the area of the sides gonna be?
2xy plus 2y.
So it's 2y, yeah, because see, look, I've got different, the sides are, it's not a square base, is it? So I'm gonna have a side here that's gonna have an area of x times y, and I'm gonna have two of those, the front and the back, right? So 2xy plus a right and a left face, and they're gonna be y times 1, so that's just y, and then two of those. Right? So that's, everybody see, that's the primary equation right there. Okay, it's a little weird, but we don't care. We don't care because we got a function in terms of, sure, two variables, but we have a constraint, don't we? What's our constraint or our secondary equation gonna rely on? Volume. Yeah, see what I'm saying? Okay, so the secondary equation then is just gonna be volume, and what's the volume of this thing? Right, but in terms of the variables, it would just be x times y times 1, so xy equals 4. Now be smart. Or does it even matter? In this case, which one are we going to substitute for? It doesn't really matter this time, does it?
No.
Right. So how about if we solve for y? Y equals, what, 4 over x? And so we'll just make that substitution. Okay? And when we do that, actually that helps, doesn't it? Then we're going to end up with a bunch of things we can just add up, a bunch of like terms. So we end up getting, when we add that stuff up, we're going to get c as a function of what variable if we're substituting for y. Okay, good. C of x equals 10x plus 5 times 2x times y. So that's going to be 2x times 4 over x. So it's just going to be 8, isn't it? Yeah, you're right. Plus 2 times 4 over x. And so that just becomes c of x equals 10x plus, those cancel, right? Do that in a different color. Do that light gray. So plus 8 plus 8 over x. I don't even really need the parentheses anymore. Oh, I didn't multiply the 5, did I? So that's going to be 40. Okay, and what's my domain going to be?
0.
X could go to 0, it could approach 0, right? Okay. If x approaches 0, that's okay, then that just means y is going to get big. How big would y get? Well, that's the volume though, right? If I make the base of this thing infinitely narrow this way, that's going to squeeze that volume up pretty high, isn't it? How high? Infinitely high, right? Okay. What about how big could x get? Well, x is going to get bigger as my other variable gets smaller, right? So as y gets squeezed down, how big is x going to be? Infinity. Theoretically, one little drop of water, if matter behaved mathematically, if I squish it down, it could get infinitely wide, couldn't it? Right? We could squeeze it into a puddle, a pancake puddle that would spread out infinitely far if I could make it approach infinitely thin, which I can't do, right? But if I could, if matter behaved like an ideal fluid, then yeah, that would work. So Now, probably somewhere in there, there's gonna be a critical number that's gonna bail us out though, right? Okay, so there's C of X. I guess we can do this all on one page. So what's C prime gonna be? That term's gonna give me 10. What's gonna happen to the 40? 0. And what about this guy? That's the same as what, 40?
X
The
negative.
first.
Good, good. We don't want to treat that as a quotient, do we? Right? If we've got a constant on top, we bring the top up to a negative power. So what's the derivative of 40x to the minus 1?
Negative 40x.
Good. Okay? And so when's that going to equal 0? C prime equals 0 when what? So let's just do the math here. So if I add this to the other side, would everybody agree when 10 equals 40 over x squared? Right? I could divide each side by 10 if I wanted and just get rid of those guys. If I cross multiply, what do I get?
10x squared equals 40.
X squared equals 4, so x must equal, okay, good. So that's my critical number, isn't it? Did everybody see that? I went through that kind of fast. Does everybody see how we got that? Right, all I did was set this equal to 0 and add that term to the other side to get that, right? Then just cross multiply and so on, okay? And then finally, this is an easy one to deal with, right? Remember, a lot of the ones we do, calculating a second derivative is trivial, so we do it. But if it's hard to do we bother? No, we just use the first derivative test. If we've got like radicals in there and stuff, we don't want to mess with another layer of a derivative that's probably going to be really ugly, right? So C prime of x is what in this case?
80 over X.
Okay, so I've got negative 40 x to the minus 2.
Oh,
So it's going to be positive 80 over x cubed. But for any positive value of x, the sign is going to be positive. Okay, so then if we do our table, we have 0 to infinity, and our critical number was 2. That was a 0 of the first derivative. We got a negative second derivative. No, positive second derivative, sorry. So this is a minimum. Is that what we were looking for? Yeah, least expensive, right? So, oh, yeah, so cost then. Cost is going to be minimized when x equals 2. What do they ask for? What dimensions minimize cost? So,
No way. It's full.
You have to find two things.
it is, isn't it? So it's, yeah. So it's going to be, so we got to find y, don't we? If, oh no, it's not. X is 2, right?
Yeah, so why is
So what's y going to be? 2, right? So if, all the way down, oh yeah, okay, so x equals 2, y equals, was it 4 over 2?
Yeah.
Okay, so 2 by 1 by 2 gives us maximum, minimizes cost. Okay, is that gonna maximize probably volume? No, it's gonna be a different answer, isn't it? And that's a real common mistake. In fact, I think maybe, when I look back, I think maybe some people did that. They thought, okay, and I understand the reasoning. Well, let's just minimize surface area, and that should minimize cost, right? Wrong, right? Because the surface area is weighted. And so if we just minimize surface area, we would get a different answer because we wouldn't have that 10 and that 5 there, would we? Right? Which is skewing things a little bit. Okay? Make sense?
We have to plug into the cost too.
Say it again. Oh, they want the cost too? So what would we do there on our table? We would just go right there, right? There's no reason to go back to the top. You could. I mean, we could just plug in x equals 2 and y equals 2, but we've already got this function specifically built for cost as a function of x. So if I evaluate it at 2, what do I get? 20 plus 40 plus 20 is 80. Is that right? So there's my cost, 80. Make sense? Okay. This stuff, this kind of stuff really does work too. I'm building a room that I'm gonna like soundproof a room at home, and I just wanna do a really good like audiophile stereo room downstairs. And when I'm doing my bass traps and things, I'm actually gonna do this. I'm just gonna sit down and say, okay, well, I'm gonna try to do a little calculus so I can save some money. Which you gotta know a little physics with that too, but just with a little bit of physics and a little bit of calculus, it works. It really does work. You can save some money. If you were gonna do something like build a shed, and the roofing would be more expensive than the walls, right? So if you were gonna build a shed, the code in Pendleton, I think, is you have to have 120 square feet or less to not have a building code. You'd wanna figure that out. You'd wanna actually sit down, and it would make a big difference. If you just made a square footprint, that's not gonna be the cheapest one to build. I think it wouldn't be the cheapest one to build, because if you had an estimate, the shingles and the insulation in the roof is gonna cost more than in the walls. And so you're probably gonna wanna make it a little bit narrower so you get less roof area, right? See what I'm saying? Okay, so.
Your question.
Infinite straight line.
All right, we're out of here in 3 minutes. Okay, so what I'm gonna do then, here's kind of my plan. What I'm gonna do is I'm going